Hello, and welcome to the Augmented Mind podcast. I'm your host, Michael. Today, I'm honored to welcome our guest, Ken Liu. Ken is a PhD student at Stanford working on AI and privacy. He's also the creator of the Open Anonymity Project, a project working to enable cryptographically secure AI inference on frontier models like GPT-5.
The problem here is that while this OpenClaw runs on your device, it says nothing about where the data is going. So it gives you the illusion of local compute, but it's not really local compute.
Why do we need Claude or GPT-5 to be able to look at every file on my computer to be able to help me? I should be able to run a small model that can figure out exactly what I need to send.
I think it comes down to incentives right now. Is there a company that has the right incentive to really provide privacy for people? I'm not too sure.
Another thing you talk about in your blog post is this idea of intelligence neutrality.
You want to be in a world where everybody gets this, like electricity and internet. It should be so abundant that it doesn't matter what you use it for. And I think intelligence should be moving towards that direction.
Hello, and welcome to the Augmented Mind podcast. I'm your host, Michael. Today, I'm honored to welcome our guest, Ken Liu. Ken is a PhD student at Stanford working on AI and privacy. He's also the creator of the Open Anonymity Project, a project working to enable cryptographically secure AI inference on frontier models like GPT-5. Our discussion spans the technical algorithms that enable private inference to the human elements that make privacy so tricky. Stick around for Ken's vision of intelligence neutrality. The Augmented Mind Podcast Episode 4 starts right now.
Hi, I'm Ken. I'm a computer science PhD student at Stanford. I'm super excited to be on the AM podcast. Something interesting and jarring about the AI systems of today is that a lot of our sensitive information go into them. It's a lot worse than Google search because these AI systems and interfaces really invite you to be more open-ended, and you will put in more information than you usually would. For example, people are putting in tax forms, their divorce documents, their bank statements, and they're having therapy sessions with these systems as we speak. We're putting so much trust on the model providers, and the stakes are really high. A big part of this podcast will be focused on a project that I recently worked on called the Open Anonymity Project. On a high level, this project focuses on building infrastructure, tools, and user-facing software for the AI user privacy and data ownership as we interface with these systems. The project has two phases. The first phase is something called Unlinkable Inference. It's a layer through which you can query remote models and think of it as a VPN for AI inference. So the idea here is that you can send a prompt to ChatGPT with neither this layer or OpenAI knows who sent it, and that this layer have no clue who this user is and their prompts and responses. The second stage is decentralized context management. The idea is that if you mediate all of your AI interactions through this layer, then you, the user, become the only person that has access to your entire interaction history. So that makes it so that you are the only person that can build a memory for yourself. Since the release of this project, we have talked to folks like the Ethereum Foundation, Mozilla Foundation, Gates Foundation, and the Human Rights Foundation to see how we can take this idea further. This project wouldn't be possible with many people who have contributed to it. For example, this includes Eric, who is my project co-lead, and student contributors such as Amelia, Coco, Mingye, Anish, Julia, and our PhD advisors, Percy, Sami, and Alex. I hope you enjoyed this podcast.
Hi, Ken. Welcome to the Augmented Mind podcast. We're very excited to have you today. And before we dive into talking a little bit more about your work, we'd love to hear about why you chose to do a PhD and how you got started on this journey.
Thanks, Michael. Thanks for having me. This is a great podcast. I did my undergrad in Australia. Like any undergrad would do, I messed around. I didn't know what I was doing. I did a lot of software engineering internships. That didn't lead to anywhere. But during my undergrad, there's something called deep learning that came along, and there's a class called CS 231N at Stanford. Took that, and then realized it's very fun, and started to want to do more AI stuff and machine learning stuff. And then as I was about to graduate, I was thinking about grad school, but then at that point I don't have any research experience, so I wanted to do a master's first. And then you have COVID. COVID comes along, and you realize it's not a good idea to do masters over Zoom. And so I went to Google, did some research there. That's where I picked up the idea of privacy and privacy research. It's a really great experience there. But I ended up leaving because I still wanted to try grad school and see what it's like. And then went to CMU and realized graduate is fun. You have one meeting every week. You wake up at 12. There's no pressure doing anything. It was really fun, and thought I wanted to do more grad school, and here I am.
Great. Well, glad that you came here. I'd love to hear a little bit more about the type of research you're doing now and how you came to this problem.
I think I was exploring quite a bit. I was doing some vision stuff, and then I was doing some RL stuff, and then I started doing a lot of like privacy research. And privacy research, by that I mean more like a technical privacy research, things like differential privacy, federated learning, and I did a little bit of cryptography stuff back in the day. I think as kind of the world changes and moves along, you're gonna have different kind of privacy problem that surface. So for example, back in 2020, it was a big thing back then to say federated learning, to have the idea of you have devices that have data, and then you want to train on the devices without the devices sharing the data. That was big, but then LLMs came along and tells you that it's not a good idea to decentralize your data. We want to put it in the same single place, and then you're gonna kind of like deal with a different set of privacy problem, like things like memorization, things like maybe copyright, and things like data controls for users. Because now if a single party is running all of that data, what does that mean for users?
Right. Yeah. Actually, could you tell me a little more about that? So, as somebody who's just using ChatGPT, what are like my biggest concerns with privacy today?
Yeah. I guess the concern would be that a single company now knows kind of like all of your chatting history, and then they can do a lot of inference on top of it. So this wasn't as much of a problem back then when intelligence wasn't as abundant, right? Like now they can literally run a GPT-5 Pro on top of your chats to infer that you're a grad student here. What do you have for lunch? Where do you go for lunch usually? And like what do you do for fun? That type of stuff. And this is fun and games for many grad students, but for some people like activists and I don't know, like people with special status, like for example you're on a visa and you want to ask about stuff and you want to organize a protest, then this is no longer fun. Like you would know that okay, there's so much sensitive data being shared, being controlled, and being directly viewable by a company.
Right. Yes. And I mean, even with the sort of Anthropic, OpenAI, all this government stuff, I think it's very interesting to discuss about this privacy with AI companies and how much data they really do have about their users.
Yeah, totally. So I think the history was that before thinking models were a thing, people were like fine. People didn't really think about it. So early last year, so 2025, that's when like O3 came out or something like that. People realized that this thing actually can reason. They can think pretty hard about stuff. In particular, they can think pretty hard about connecting things from different pieces. And then the idea of memory came along. Okay, so when you use ChatGPT, you should like know what the user have been up to in the past. And I think in the middle of last year, like memory became like very, very prevalent. People are starting talking about it. It's helpful. And then fast forward to like the end of the year, like you start to see people saying like on Reddit, on Twitter, like, damn, like this ChatGPT knows so much about me. Like it's scary. It's very uncomfortable. And then early this year, you start to have things like the Department of War deal, like people talking about mass surveillance, which is, I guess, there's a different angle to that, like using that technology for mass surveillance versus like having that data inside the company's databases. And then, very recently you have Bernie Sanders, talking to Claude about AI user privacy. It's the idea that, well, this chatbot knows so much, and he not only knows so much about user privacy, but also knows that it itself is very not good for privacy, right? Like Claude says, I'm not good for user privacy. Yeah. Very funny. So the awareness, I would say, is like going up since the last year. So that was kind of the...
Yeah, definitely. And I'm curious, so as a user of ChatGPT, like what you're saying makes sense to me of like, it can look between my conversations and make connections and learn things about me that I probably wouldn't have been comfortable sharing. I'm curious, as somebody who works both in cryptography and deep learning, what type of unique perspectives you have about maybe how to tackle this privacy problem.
Yeah. I think my past research really gave me this kind of I would say 3 perspectives on privacy. The first is like, how do you separate data? Like how do you structurally separate data? Like what data sits where, what data sits where? It's like a principle. How do you manage it? And second idea that I learned from maybe cryptography is that you want to have things that are provable, right? You don't want things that are like wishy-washy and it's like certain companies.
And what do you mean by provable here?
Provable mean that there's math. You can actually check the math, or you can check them maybe like secure hardware. There's some technical mechanisms that you can rely on as opposed to someone else's promise, right? Like someone else's pinky promise. A third kind of principle that I learned, this is from DP, studying with differential privacy, is the idea of like statistics and noising. Like how can you introduce noise and entropy such that like even if you compromise the system, there's no way you can like, get that data back because it's information theoretic, right? So the data is no longer there, so to speak, right? That's a very like very powerful principle actually, and that's kind of covers the worst case. Yeah.
I think that leads us nicely to talking about your project, the Open Anonymity Project. So I guess you released this blog post recently where you said AI presents a uniquely worse privacy problem than things like search engines and social media. So could you explain a little bit about why, I guess, AI adds such a risk? I mean, the social media companies have so much data about me already. What makes AI kind of a bigger problem?
Yeah. I think the first thing, and this is relating to, I think the theme of this podcast as well, is about how humans are interacting and what interfaces are being presented. I think the very, very first thing is that the format of interaction is different. In the past with social media or with like web search, you're like, here's a specific keyword, or here's a specific post I'm okay to share with the world, and here's a video that I made about something. Whereas with AI, it feels like you're private. It feels like you're talking to an entity that does not reveal this information, and so that invites kind of like more open-ended answers. Like you don't do 1 hour therapy sessions on Google search, nor would you do that with Instagram. But now you do that with ChatGPT, and people do that with ChatGPT, and people don't upload text documents to Instagram and Google search, but now you do. And so like just the amount of stuff that people are now more willing to put in just because of the interface and because of like how it makes people feel.
I see. So you think it's a perceptual thing, like the user is more willing to share with an AI?
Yeah, willing to share and how the interface kind of like formats it, right, so to speak. I think that's only the first component. The second component why it's worse is because you now have intelligence. So I think a common argument you get from comparison with privacy now versus the past is that in the past, I also have Gmail, I also have Google Calendar, I also have Google searches. Like, you would know it of my life. What happened now? Why is it different now? I think what's different now is that it used to be that you need someone to look at your account and say, Michael has received this funny email from this group that wants to do some stuff, right? Like, and then look at your calendar and decide, okay, maybe Michael's up to something. But now all of that's automated. You no longer need to like get a human to look at it. Like it wasn't scalable to violate your privacy. Now it is scalable to violate your privacy.
Yeah.
Yeah.
That makes sense.
And it's almost like what matters is the insights that come from the raw data. Like knowing that Michael would love to go to this restaurant every week is a very valuable insight that doesn't present itself just from the raw data, like raw emails and raw calendar.
Right. Yeah. Makes sense. Well, then I'd love to talk a little bit more about kind of how you're tackling this. So I mentioned the Open Anonymity Project, and I feel that the major contribution of Open Anonymity is this unlinkable inference layer for AI. So for our viewers who might not know, could you, I guess, define for me what unlinkable inference means?
Yeah, I think there are two words. There's unlinkability and there's inference. I think inference is easy, like tokens in, tokens out, off of some model. Unlinkable means that whoever runs that model, tokens in, tokens out, have no clue where this request came from. And if you have 10 requests, they cannot tell, at least with certainty, like which came from which user. And then, so if you get 10 requests, you cannot tell if it came from 10 person or 1 person. And in particular, none of that has any user identifiable information. So all you see is just a pool of prompts. You can try to guess that it came from like 2 users, but you will never know for sure.
And how is this different from like pseudonymity, where I guess, yeah, could you describe that?
So pseudonymity is the idea that you have a real name, but then you replace that real name with a fake name, so like with an alias. And the thing with aliases is that it still tells you like this is the same person, I just don't know who. And so like over, let's say, 10 requests, if you have 2 pseudonyms, I know that it's from 2 people. Whereas anonymity is saying that there's absolutely no like this linkage handle. There's no alias, there's no fake name. It's just prompts. Like you remove the metadata. And I think the linkage is what makes things worse, actually. So I think it sounds very close, pseudonymity and anonymity, but that linkage makes all the difference. Right. Because if I can see that this is the same guy who posted on Reddit and same guy who went on LinkedIn and do other things, that gives the attacker much more advantage because information compounds, so to speak, right? You have this piece of information, you have that piece of information, you can derive like way more information from the 2 pieces than the individual parts.
Right. That makes a lot of sense. So I'm sure that many of our viewers will be familiar with something like light LLM. So I want to ask you, what makes this different than something like a private light LLM proxy?
I think at the end of the day, it comes down to trust and verifiability. So suppose that your user, here's OpenAI. Right now, you send all the prompts to OpenAI. OpenAI, you're trusting OpenAI to not do certain things, but OpenAI knows everything about this chat history. If you simply add a middleman that has absolutely no guarantees, then this middleman becomes OpenAI, right? Like this middleman would literally take all your data. They can run GPT-5 for Pro just like OpenAI would. They can still infer you. They still have the user identity. So what you want is a middle person that does not have access to the prompts and responses. Like it has to be a blind kind of like proxy. And second, it has to not know user identity. Like if it knows user identity, it also like leaks something. It helps to not know the prompts and responses already, but it's best if it also doesn't know the identity of the users. So I don't want to see, Michael came along and asked 10 questions. I don't know what questions, but just the fact that you asked 10 questions, it's still like a leakage. And so when we look back to, these privacy initiatives all over the place, you realize that none of them, very little of them, have like actual guarantees. The most common form is someone comes along and say, we are, AI privacy provider, and we're private. But you've looked at their privacy policy, which is, by the way, legally binding. You realize there's absolutely no privacy. It's completely non-private, just because they can see everything in the middle. So essentially, you want 2 guarantees. You want confidentiality of your prompts and responses. Yeah. You want integrity. You don't want them to mess up with your prompts and responses, like replace certain model responses with another. Sure. And you also want like blindness, like in the sense that I don't know who this is.
That makes a lot of sense. I mean, earlier you mentioned provability as a core component to the way that you are viewing kind of like cryptographically secure privacy. So I'd love to talk about from the technical side, maybe even just through high-level analogies and stuff. How do you provably guarantee this privacy? For example, when you say that the inference, the server doesn't even know that I've issued a request 10 times, like how do you manage something like that?
Yeah, so I guess this gets to the specific approach. I guess it's also like described in the blog post, but I'm really happy to talk through these components. At the end of the day, there are 2 components. There's components about blind authentication. That means like when you prove to this infrastructure that you're a legit user, you're not just like some spammer from elsewhere, you need to show that you, let's say, quote unquote, paid without revealing who you are. So it's like paying by cash, right? Suppose you have a lot of cash, you go to a store, you buy some stuff, then it's blind to the store doesn't know who you are. So there you can use all sorts of like cryptographic mechanisms. Something that we use is called blind signatures. Mm-hmm. The idea there is that suppose you're a user, the infrastructure, you give me $10, I'm gonna give back to you 1,000 coins. Mm-hmm. These are not the blockchain coins, sure. But like some token that are unlinkable to you. So the way it works is that you will give me 1,000 random numbers, and then you apply like a mask on top of the random numbers. The mask will look something like exponentiation in the final field, and you take over, give it to me, and then I will sign them. And the way I will sign them is basically adding some extra arithmetic operation on top of it, and I return these numbers to you, and then you can remove the blinding mask that you apply on top, and the signature will still persist. So that means I signed your random numbers without seeing your random numbers.
So it's essentially like I'm buying like these tickets that allow me.
Yeah. We call them tickets in the OA system because they, it's like a ticket you can use. Exactly. So what's really important about this is that I never see the original numbers. So when you do present to this layer that says, I possess this ticket that Ken signed earlier, this will be the first time anybody would have seen this ticket because you blinded them before. Now you remove the blind.
I see. And there's no way to link back that I was the one who purchased this ticket.
No, just because this is the first time I see this random number. Like to link back to you, I would have to know, okay, michaelryan.gmail.com, gave me this 1,000 blinded version, but then those versions are gone.
Right.
It's no longer no one has them anymore because you remove the blind.
That makes sense. And once you have these tickets and you cache them in on the server, then how are we doing the actual guaranteed transmission of the data, right? Because you said that another risk is the proxy layer, and maybe proxy is the wrong term to use here, but that they could swap out your prompt or view your prompt.
Exactly.
How do we guarantee that that doesn't happen?
Exactly. So I was saying there are two components. I guess we now explained the blind authentication component, and now it's the secure proxying component. So secure proxying, back in the networking days, today it's still networking days, is the idea that you can send some traffic and this proxy does not see anything beneath. So VPN is exactly a secure proxy for network requests. Any VPN node, if it's legit, it doesn't see anything that you're transmitting. It just relays encrypted blobs, and so you and the other party agreed on some symmetric, encryption, and then you just transmit, and it just simply relays the traffic. The trick here for AI inference is that you're now relaying prompts and responses, like these texts, right? And in particular, you want the proxies to not see this text, yet you want to use someone else's credential. So for example, let's say here's some proxy in the middle. I'm OpenAI. You're a user. If you authenticate to me using your own API key, then no matter how many proxies that's in the middle, no matter whether the proxies see the content or not, I'm gonna know it's Michael because you present your API key.
Right.
So you're gonna have to use someone else's API key. And in today, when you craft a request, you need both the API key and the prompt, right? You need both to actually send that request. So you want a proxy's API key. Then the trick is how do you ensure that the proxy does not see your response? There are a couple of approaches. One approach is, as the simplest approach, and a lot of people do this, is the idea of a secure hardware, or TEs, trusted execution environments. The idea there is that I'm going to write a program. This program says, I have API key, I'm going to take in user responses, and I'm going to send it to OpenAI, and done. It's a simple program. And this program you're going to publish to the world, and then what the secure hardware can help you with is that the secure hardware can prove on the hardware layer that this is indeed the program that was run on this node, as opposed to some other program. So intuitively, to think about it, imagine the secure hardware can spit out a hash of the program, and then the program is available elsewhere, and you as a user can verify the hash match. So that means you have integrity of the program, and then you know that this program isn't doing any logging, doing anything shady, so you can trust it, right? So that's how you verify. So that's the first approach. The second approach is relying on, let's say, with some third-party infrastructure. So if this proxy allows the idea of giving you the API key as opposed to you send over the prompt, then you can, for example, this proxy can send some sub key or one-time key to you, and you make this request with a one-time key. So for example, OpenRouter allows you to do that. In right now with OA infrastructure, we do use a lot of OpenRouter proxies in the sense that suppose you come here, you give me 5 blind signatures, which makes me not aware of who you are. I'm gonna give you $1 key $1 key that lasts 20 minutes, and you can use this key however you like. But then you don't even talk to me anymore. You talk to OpenRouter directly. Right. So it's a proxy that gives you back the key. The trick there is that you have to ensure that this OpenRouter account doesn't do anything shady, because it can also talk to OpenRouter and say, can you give the prompts and responses about this user, about this key from OpenRouter. So it colludes with OpenRouter. There you can do some extra checks. You can be here's a separate auditor that continuously and randomly audit this account to make sure that that doesn't happen. But that goes into the weeds of like how do we like secure the system. There's a third approach, which is very, very fascinating, and we didn't talk about it in the blog post, is the idea that you can do some form of MPC.
What is that?
MPC stands for multi-party computation. It's like some like cryptographic kind of approach where different parties can together do some computation with parties not knowing each other's inputs. So in this case, the proxy knows the API key, which you would like to use. It's like borrowing someone else's ChatGPT account. You are a user. Is there a way for the two of you to craft a request to OpenAI together without them seeing your prompt and you seeing their API key?
Interesting.
And it's actually doable. We thought it's not possible. It's actually possible. You do have to do some interesting network stuff to make that happen. And once you get it done, it's actually very, very neat because you now no longer depend on any kind of like you don't need secure hardware, which is expensive. You don't need a third party like OpenRouter to help you achieve this.
Interesting. Let me see. So if I understand correctly, the first method with the trusted execution environment, if something like Lite LLM had guarantees in their open source code that they weren't storing any of your prompts or anything like that, someone could set up a trusted execution environment, and Lite LLM could serve as this proxy in that case.
In fact, there are definitely people who are running TE proxies, like secure hardware proxies right now today. So it's not the first thing, like we're just using it as a component. But the blindness is also very important. You need to have that blindness to complete the whole system. I will say though, very importantly, the thing with secure hardware is that you do have to open source stuff. You cannot be like, oh, my stuff runs on TE and then it's private because it's secure hardware. No, the reason is that you have to attest it. Attest means that you have to check, as a user, you have to check what the TE is running and what part is it running. And it's actually very hard to get secure hardware right because imagine you have this node that's in the middle and you give it your prompt. You have to check the web server that like receives this request. This is not even like the GPU yet, and you need to check that okay, this web server doesn't have like some other nodes in the behind to know that okay, what if I secretly, this is safe but this is not safe. I secretly relay that.
Monitoring the traffic on the
and then
server.
And then you need to like attest. You also need to attest the whole chain, so to speak, because as soon as the prompt leaves your device, there's the web server, there's the load balancer, there's the edge, there's the GPU, and there's so much stuff you have to attest. And so, again, attest meaning that you check for yourself that this is actually true. And Apple did a great effort. There's something called Apple PCC, Private Cloud Compute. It's the idea that Apple tried very hard to make you be able to attest almost everything. Almost everything meaning that you can actually check that, oh wow, when I request leaves Apple Intelligence, which nobody uses, on the server, here's parts that that you can verify. But even they cannot do the whole chain. There are still parts that they don't feel comfortable open sourcing. Hence, like they just invite security researchers to come in and say, okay, please audit this for me, and say that we're secure. It's really hard to attest the whole chain. And I think there are people who are doing this right, and like very few people are doing this right, I think.
When we talk about attesting the whole chain, I'm curious. I think something that's nice about your unlinkable inference is that it allows you to use the frontier models, which are closed models, so we can't attest the whole chain. But I'm curious what work has been done on like open weight models. Is this something that you could actually attest the entire compute chain?
Exactly. Yeah, I want to address the threat model here. As always see with the OA project, the threat is not that you don't want the prompt to be seen by the provider because they have to see it. You want to use Gemini, so they have to see it. It's more that anything before Gemini removes your identity, like gives you anonymity, provable anonymity. Whereas if you can actually run a model, let's say open weight model, and you own a cluster, then yes, you can do it the whole chain. It takes a lot of work, but you can do it. There's a startup I want to call out. It's called Tinfoil. I think they're doing very good work. What they do is that they try like make it very, very easy for you to like check a lot of the cases and attest for yourself. And it's actually like non-trivial to be able to do that. Yeah.
That's very interesting. Yeah. And is this something where it would be on a cloud platform, you'd want to host like a frontier size model. But does this slow down the inference at all to have to be able to attest this? Like, is there a compute cost to being able to do that?
Yeah, good question. Actually, the way it would look like in practice is that, let's say I want to do open weight models and I want to attest to you like the entire chain. So no longer, again, OA, this is not OA. This is just like, actually we'll probably get to that. It's called confidential inference. It's the idea that I'm going to run a web server, I'm going to run the GPU cluster, and I'm going to shove the open weight model in there. The way it would look like is that the program is simply VLM run the JAMA for, okay? It's a very short program. And this program, you publish. And in this program, and then you put it on the GPU and the web server, and then you just give all the attestation kind of like hooks, so to speak. So you can like, okay, check, this is fine, check that, that's fine. And it's a simple program. And so like you know from end to end that's basically secure.
I see. So it's mostly just checking that you're running the program you're saying you're running, but it isn't actually a huge cost to like you don't have to add these hooks throughout the whole VLM server because the VLM code is open source.
Yeah, because it's more like because your program is not doing anything fishy, you're just using VLM. Now there is what people call supply chain risk. Someone could have get a malicious patch into VLM, and then they could coordinate with this confidential server. I'm going to use a specific version of VLM that exploits a specific vulnerability. That's possible. It's possible. It's possible. I don't know if it happened because VLM is big. It's your esteemed guest from last episode. I think they will make sure that there's no bad patch in there. But it's hard to say because we did see like a couple of supply chain attacks in the last month. Right. I think. Yeah.
Yeah. I'm curious. Another part of open anonymity that's maybe not talked about as much is I guess. To transition to this, one big threat surface is like people just giving their information out in the prompt itself, just saying a bunch of stuff that's actually not privacy preserving. So I know one thing that you do is like actually there's like a tab rewrite prompt. And so I think I'd love to hear a little bit more about what that is actually running behind the scenes, how it swaps out this information, and does this use those like attested open models?
Yes, totally. I think this is a good question because it touches on like kind of like this roadmap of what OA is today and like what we want to do tomorrow. I think today, as you say, like it's an anonymity layer. You send a prompt, no one knows who sent it, and then the layer doesn't know anything. But if the prompt says, my name's Michael, and then here's my CV, by the way, here's also my therapy session. There's absolutely nothing you could do, right? Like anyone who observes on the other side, even without any user identity, knows that this has to be with high probability, Michael. Yeah. And so that means like anonymity layer is not going to be the only solution. It's just going to be a tool. This tool is very useful. It can already give you a lot of protection. In particular, if you think about what's sensitive, oftentimes there are two camps. One camp is that the content itself is very sensitive. You upload some company yet to be released financial report, that itself is sensitive enough. But if you say, I would like to organize a protest, and I would like to do it in this way and that way, removing the identity actually is enough in all of these cases, right? Because anybody could have asked this question. And so it's like there are identity-bound questions and there are like content-bound questions that make it sensitive. So if you say, where do I get antidepressants? This is the type of question that if I know Michael is asking, then that's good. That's not good. Yeah. But if I don't know who's asking, then no one cares. Like it doesn't matter. Like go ahead, please. Track me. Like there's no way you can get back to it because anyone could have asked that. Yeah. Moving forward, I think you mentioned the idea of like tap and kind of like how do we combine other tools, right? The future is going to be a composition of many of these tools. There's going to be this anonymity layer, unlinkable layer, and then there's going to be either local models or confidential models that help you organize your data. So in a very simplest form, as you mentioned, you can try to remove PIIs. The way we kind of implemented it in the chat is to get a confidential GPT-OSS 120B. You could use something like bigger and slower, but that's the right sweet spot. You literally just say, here's a prompt, remove all the PIIs, and then also rewrite the query while you add it to make it like remove the style and all that, and then it will just return to you. Because you can attest the whole chain, that's like almost equivalent to local inference if you trust the hardware. Right. Obviously, if some people say I don't trust the hardware, I don't trust NVIDIA GPUs, right? Then you should go to local inference. Yeah. But more broadly, it's not just going to be PI removal. You can do a lot of things with like this kind of like separation approach, right? We mentioned earlier that you could do certain things in a secure environment and then only like treat this unlinkable layer as the exit point. You can, for example, think about personalization in the secure environment. You can build a lot of memory about yourself in the secure environment, and you can be like, for this query, help me decide what to attach. So it's almost like selective disclosure. We'll probably get to that a little bit later as well. But like, if I ask, what do I want to eat tonight? There should be something that helps you decide what to attach, right? It's not going to be your tax documents, I hope. It should be like, oh, I like to eat fish. I like to, drink coffee, that type of stuff. And then you can, and that's a perfect job for like a weaker open weight model and confidential model to do.
Yeah, I mean, I think that makes sense. And maybe it makes sense to actually talk more about this now. I mean, I feel right now there's a big wave of kind of like local agents and like OpenClaw, for instance. And I think there's a whole host of privacy nightmares that come with that. So I'm curious what if you've been thinking about some of that stuff, about how do we add privacy to these models that, or not these models, these agents that are built on top of the frontier models, at least today. Is there a way that when we have access to all the user's files and all of this data about the user, that we can still manage to preserve privacy?
Yeah, this is a very good question. I think there's a very big misconception that we'd like to address in general with like agents like OpenClaw. First of all, OpenClaw is a very good project. But what is it at the end of the day? It's a message interface, like it handles like Telegram, WhatsApp, all that stuff for you. It's an agent core. The agent core is like the loop, basically the Python loop that sees this, do this, sees this, do this. Agent core, I think, came from another open source project. And then there's the memory, like it sees things and it writes it down. And then there's a bunch of skills, which is like prompts, basically. And then finally, there's the intelligence. There's the electricity, so to speak. Like, what are you plugging into? The problem here is that while this OpenClaw, so as I describe it, is really just a program. While this program runs on your device, it says nothing about where the data is going, right? Because the program can run your device, and this program can literally upload your data. Yeah. And then that really depends on who the intelligence provider is. So if you plug in Claude and ask OpenClaw with your files, it's really like uploading the files to Claude, Anthropic servers, and then like help you like form this memory. So it gives you the illusion of local compute, but it's not really local compute. And many people say that, oh, I got a Mac Mini. Yes, you got a Mac Mini to run your Python program. you're not getting a Mac Mini to run your intelligence, which powers the Python program. So this is a very important distinction. And so like, I think it's very like it really shows a lot of like possibilities of how agents should be. But there's a missing kind of like separation between what stays local and what the intelligence could provide. I think you definitely want confidential inference for a lot of this stuff. So that means that you want OpenClaw to plug into a kind of electricity that you can attest, right? Let's say some key 2.5 sitting on Enclave. But then that makes it not useful because it doesn't access the web. Because if it accesses the web, it breaks the security boundary, so to speak, right? Like, what you're testing is like this kind of sandbox. This is where like something like OA can come in very neatly. So you can expose like a specific set of tools to say, you stay in this confined boundary using confidential inference, but anything you are not sure, you can ask Gemini, but you ask in a way that without any identity. You just like relay that to Gemini, like, please help me, Gemini, what to do here. And then it's gonna be a contextually bounded delegation, so to speak. And this is basically what the next phase of this OA project is going to be. Like, we want to demonstrate this whole chain, that you can separate the kind of the agent and the external help with like more powerful intelligence. So a dumber, so to speak, model agent, but very powerful places you can delegate. Yeah. So I have an analogy for this. Suppose you're a billionaire, maybe you are.
Not yet. No.
You might have a human assistant that runs around you, and this human assistant knows everything about you. And the reason for that is that you trust it very much, and then you can get legal contracts to make sure that this person does not reveal your stuff. And then when you ask this assistant to do some stuff, you will be like, I know everything about Michael. I know that he likes to eat fish. So when I order DoorDash, I'm going to review that to the DoorDash, which is external. It's not going to review your tax documents. It's not going to review your health information. Right. And so what you're seeing here is almost like a delegation and selective disclosure behavior. And we think that this is like doable. Right? I think this is doable right now today. You have the components to kind of implement something like that, where you have a very trustworthy and provable kind of like secure environment for the agent for you to interact with, and anything it isn't sure, you can just go elsewhere. Now, you could fire the assistant in the same way that you could like delete the memory of this local confidential agent. You can get a new assistant, but then you have to onboard. But in this case, you can also like onboard like new behavior. So it's almost like you get to control your data now.
Yeah, I mean, this makes a lot of sense. I feel like it's actually, when you come and talk about this, it almost sounds silly to me to say like, why do we need like Claude or GPT-5 or Gemini to be able to look at every file on my computer to be able to help me? Like, I should be able to run a small model that can figure out exactly what I need to send, and then we can make it as private as possible and then send that off to like the frontier model to do like the deep reasoning. Yeah. Why do I need the frontier model to know every single thing about me to figure this out?
Yeah, this is a good point, because for certain tasks, you do want it to know everything, like coding. Like, for example, you do want to upload the whole repo so the thing can index and search. Even in that case, there might be a way to separate the indexing and the search, and the reasoning. So, for example, you can have a local index, and then the remote model query your local index, so you review just the right amount. But then it doesn't quite make sense. It's better if you upload the whole thing. But for personal stuff, I think it's way more natural, way more like amenable to have this like separation. Suppose you're running like a secret project, and you want to run deep research on top of it. You might not want to upload the whole thing to ChatGPT, but the way you would do it as a human is that you look at the project. What are some questions I can ask, like independently? Like maybe let's say you're studying VLM, right? Maybe you want to understand the state of the vision world. How are people doing this? Like embedding stuff. You could literally craft a sub-query or like a sub-decomposed query and offload that to Gemini. And you can craft another question about like, how do people, what are scaling laws for VLMs? Do that for ChatGPT. And if you do this through this unlinkable layer, they would just look like some people asked, like someone, in this case an agent asking this, but like someone asking this question that anybody could have asked. So if they cannot link all of this together, you cannot get a picture of what you're working on. Like this decomposition is actually very helpful for privacy. Yeah. And you can get your deep research done without revealing like the core idea of your project.
That's super cool. I really appreciate talking about these like details of the project. I'm also curious, as you were working on the Open Anonymity Project, if there are any like interesting kind of stories and decision points that kind of led you to making this.
Yes, a lot. I think when we started, it was around last summer-ish, we don't know what to do. It's just an idea that maybe you could add a layer between you and OpenAI. What does that look like? We have no clue. Initially, we were relying on some networking tricks that didn't work out. And then I think, here's one fun story. I think I was talking to Percy, my advisor. At that point, Cloco started to become a thing. And he was like, why don't you do a CLI for this stuff? Isn't CLI what everybody's into these days? And we listened to him. It was a very bad decision. And so there is a CLI version of the chat client that I think some people are using today, the OA chat client. It's completely dead. No one should use it. But we did spend at least a month or something on it to make it nice. It just didn't make sense at the end because you cannot do math, you cannot do latex, you cannot do a lot of stuff in CLI. I think you just go around and do things. I guess that's before the project, but after the project there's some interesting stuff. After the project, when we released it, there's a certain
AI privacy company that says they've built the same thing. They didn't. It's unfortunate, and they really like try to like hype their thing up. And it turns out that they have a coin, like a blockchain coin in a sense, associated with their company, and it's quite bad. I think they didn't realize that in their privacy policy, which again is legally binding, reveals it all, that they have absolutely no privacy. I think they've changed so far because of that. They called us, they quoted on Twitter and said, oh, well, we built the same thing. And I said, no, you didn't build the same thing. And then they back and forth. I think they now apparently start to like implement some change that actually improve people's privacy. I don't know what will happen next, but you really get a lot of like privacy washing companies, right? That say they offer this, but in reality makes it much worse. And this is where I think the technical view of privacy helps. Like you need to understand what that means to make people more private, like how people control the data. And what's really funny is that at the end later, as we keep going, we started talking to Ethereum, Ethereum Foundation. We don't do any blockchain stuff, but then they said this is cool stuff. They're bringing something similar. They want to like have this like layer of zero knowledge APIs, which subsumes like unlinkable inference. And then they have their proposal. I've been talking to some of these folks, hop on call with Vitalik Buterin, which is very fun. This chill guy. We were like just talking about stuff.
Is he a creator of Ethereum, or?
Yeah. I think he's one of the co-inventors of Ethereum. He's obviously he's one of the, he looks like a dude, but he's like obviously worth like bajillion times more than I do. But like I think they are very helpful. David on the Ethereum Foundation side, who wrote the project, and we're working with someone else on their team as well. So it's very good that they acknowledge that this is actually a thing and something that they want to implement. And so on one hand you have people who want to shield their own coin, and on the other hand you have the the philosopher king of the of the crypto world to help you out on this. This is very, very good to see like this kind of like support and like non-support.
Very cool. And the other thing I wanted to come back to is talking about privacy washing, and I guess this would be a good time to transition maybe into your vision for the future and how the world is now and how you see it going. But I'm curious if you think like AI companies are taking privacy seriously, or I know you mentioned Apple, for instance, has this Apple Intelligence Attestation. So what do you think the current landscape of privacy in AI looks like, and how do you see it changing?
Good question. I think it comes down to incentives right now. Is there a company that has the right incentive to really provide privacy for people? I'm not too sure, because let's say OpenAI, for example, they want to do ads. That's something that's kind of against the incentive of giving user provable privacy. Also, like we're in this tremendous kind of acceleration phase where people want to throw as much on growth, on capabilities as possible. So privacy is really afterthought. And so like it's unclear to me that the big frontier labs, they're like here to deal with this right now. I think they are thinking about this, definitely. Like for example, I think people told me that OpenAI is thinking about doing a confidential inference, but I don't know when that's going to look like and whether it's like Apple. Can you release the whole chain for people to test? Or at the end of the day, I'm still trusting you a little bit, right, with like less than what I do today, but a little bit less. I think it's really the incentive that drives your behavior. And so one of the reasons we kind of did this project is like we look around and we're like, there's no alternative. Why don't we just do something ourselves? And we can set up this project in a way that it's very like neutral, like incentives aligned to helping you get more privacy. Like, for example, if you were to like sell this OA chat service, I think some people were asking us to do that. We're a research project, we cannot do this. But if you do, then you can make it clear that the only thing we're charging is just this tokens. It will be a little more expensive because there's going to be a privacy premium, but like that's the model, right? You almost want like an Apple or like a Proton for this stuff, but you don't quite.
What do you mean by that?
like a company whose business does not depending on getting more and more data. So for example, Google and Meta, they're gonna say they're gonna do personal intelligence, right? That means like they have lots of your data, they can build a AI that's like personal to you, but their businesses are kind of like fundamentally tied to having your data work for them, right? Like maybe they can now get very accurate ads with your G Suite data. I don't know how they're gonna monetize personal intelligence with G Suite. That's what they're gonna start with. If people are so used to paying, like not paying for anything for Gmail, Google Docs, and Google Calendar, you bet that there has to be some way to like pay back that personal intelligence, and it might not look good, right? Right. So that's that.
Yeah, I'm curious. Another thing you talk about in your blog post is this idea of intelligence neutrality, and I think it was potentially inspired by like net neutrality. And I'm curious what you think the world looks like, maybe with and without this notion of intelligence neutrality, and maybe you could define what that is.
Yeah, I mean, it's just a catchy term to be thought of. Percy thought it's a good idea. I thought it's a good idea. We just put it on. But okay, to be serious, I think there's definitely a lot of analogy and connections you can draw with net neutrality. Imagine AOL decides that because everybody visits YouTube, you're gonna cost more to visit YouTube. It decides that when I sell you an internet plan, you don't get access to social media. Here's a basic package. No social media. No social media. You can access Bing.com. Right? No Instagram.com. And then the premium package, right? That's not a world we want to live in. It's like it should be so abundant that it doesn't matter what you use it for. And I think intelligence should be moving towards that direction. People are compressing the cost a lot. It's generally available. Open weight models help a lot. You want to be in a world where everybody gets this, like electricity and internet, and you're like, it's so cheap. I don't care what you do with it, because on the other side they're gonna do a lot of like content like if they want to do content moderation, like I don't want to serve bomb requests, then they don't serve it, but don't use that as an excuse to track you, right? To give you different pricing plans, right? Like don't use that to implicate you. So that's kind of what it roughly means, right? You have a neutral provider, like it's a public utility. And I think if we really kind of think about the analogy of electricity and intelligence, like Andrew used to say that like AI is new electricity. If you really embrace that, then you really need to have infrastructure in place to make sure that everybody can access. Like we're plugging to this wall without asking anybody, right? You should be able to just use it.
Yeah. That makes a lot of sense. I have a potentially tricky question based on what you said there about like the bomb example. So both from like a safety standpoint, where it's like maybe there is a legitimate concern that people could use these models for harmful practices. I guess, do you see like open anonymity as a risk factor in that safety space?
Totally.
Yeah.
It could be used for distillation attacks. I think there was actually an attacker to our infrastructure.
Oh, wow.
The last 2 weeks. There's someone who somehow gained control to the entire IP range, so they can like generate a lot of like requests that seem like real users, and then they can somehow also control a lot of like domain names, so they can generate a lot of like emails. So for context, like we only ask for email to make sure you ID duplicate, and I check the IP address to make sure that it's not the same person asking for so many tickets. But once you get the tickets, I have no clue what you're doing with it. So like in principle, because we don't know what's going on, like with the prompts, you can imagine people like using this as an abuse tool. But at the end of the day, I guess there are two comments I can make. First comment is that privacy technology is fundamentally kind of dual use, like things like Tor, things like encryption. Do you want the bad guys doing encryption? So no encryption for the bad guys, encryption for the good guys. Then that's not encryption. I mean, you found the backdoor. Yeah. Same thing with like anonymity networks. Second is that I think the world is obviously operating in this way of staged release, like tiered kind of like a release. The best and the smartest model are not going to be available for general use initially, but with this tier, with this ladder of capability, you always kind of like just grow as a whole. Like now, the open weight model that anybody can access is more powerful than the original ChatGPT, like 10x more powerful, 10x faster. So you don't have to have something like Open Anonymity support the latest model. You just for the best model. However, we do want to be very, very close to the frontier. So like, in principle, you could still set up a proxy that asks, that gives ID to Anthropic and then serve as a proxy for this Open Anonymity network. That's still possible. So it's just like, how do you handle the abuse problem? You could handle it two ways. You can handle it on the payment time. So for very, very capable models that you're proxying for anonymous access, you might want to ask for ID in a similar way, but there's a huge difference because the blind authentication layer separates the ID, your identity, with your usage pattern. So once I let you into the system, I don't know who you are, I don't know what you're doing with it. That's a meaningful difference between like Anthropic saying that when you sign up for your ID, I know exactly who you are, I know exactly what you're doing with that model. So you could imagine setting up like stronger like KYC type situation for signing up to Open Anonymity, but not when using it. Because I'm just going to give you the tickets, and then it's a special kind of ticket that only works for this proxy.
I see. So you're actually managing to kind of get somewhat of a best of both worlds, where you can verify that this is a person who is maybe able to, we can trust that this person won't use this for harmful means, but once they have access, then we won't know what they're doing.
Yeah, and then there's obviously like some like dependence on this person not being a bad person later on.
Right.
Like let's say, Michael, you're a good person today, you sign up to the service, you pay it $200 and you gave us your ID, and then secretly you're working with like, I don't know, some adversarial nation, as they call it, and give your access to those. Like that's something that we cannot stop, right? Because when you have access, and I think, but then that problem is the same with Anthropic. Like when someone signs up, they can still give it to other people to use, and there's nothing Anthropic can really meaningfully like do there. At the end of the day, I think abuse prevention should be a model provider's job. Like if you realize that people are asking bad questions, cybersecurity questions, what happens today is that they just block the request. And you can do that without knowing who this is. And I think that should be the way, right?
Cool. Well, thank you so much for coming on our podcast today, sharing all of this very cool technical work on how to keep AI inference private. I feel like it's a really great vision that you have, that we can both have frontier level intelligence and also maintain our privacy. I think that like when you talk about this, to me that makes perfect sense, that this should be the world that we live in, and I love that you're working towards this vision and have accomplished like some really, really great progress in that way. So thank you so much, and we wish you the best of luck with your Open Anonymity project.
Thank you so much. Thanks so much for having me, Michael.